Lesson 2 Vlog Script Exercises. Lesson 2 Problem 1 Sending debug information from Arduino to your computer. Hey, tech enthusiast! Welcome to our educational vlog. Today, Group 8 from GROUP8 CT3-1 is diving into the world of Arduino with a cool project that explores serial communication. We're going to show you how to send text and data from your Arduino board to your computer's screen using the serial monitor. It's a fundamental skill for an Arduino project that involves communication with a computer. So let's get started. Here's what you'll need. An Arduino board. We're actually using the left VIN today. A USB cable, a board, some jumper wires. Once you have your materials, follow these steps. First, connect the Arduino to your computer. Use the USB cable to connect the Arduino's USB port to your computer. Second, open the Arduino IDE. This is the software where you'll write and upload your code to the Arduino. Third, write the sketch. Copy and paste the following code into the Arduino IDE. Fourth, explain the sketch. Let's break down this code step by step. The setup, open and close parenthesis function runs once when the Arduino starts up. The serial.begin, open parenthesis 9600, close parenthesis line initializes serial communication at the baud rate of 9600 beats per second. The loop, open and close parenthesis function runs repeatedly over and over again. Inside the loop, open and close parenthesis, the serial.print, open and close parenthesis, and serial.print in open and close parenthesis lines send text and the value of the number variable to the serial monitor. The delay, open 500 close parenthesis line pauses the program for 500 milliseconds or half of a second. Finally, the number plus plus line increments the number variable by 1 for the next loop. Step 5. Upload the sketch. Click the Upload button in the Arduino IDE to send the code to your Arduino board. 6. Open the serial monitor. Click the serial monitor button in the Arduino IDE to open a window where you can view the data being sent from the Arduino. 7. Observe the results. You should see the text "the number is" followed by a number that increments every half a second. Congratulations! You've successfully sent data from your Arduino to your computer. Now, you're ready to explore more complex projects that involve serial communication. Stay tuned for more awesome Arduino tutorials and projects from Group 8. Problem 2. Sending formatted text and numeric data from Arduino. Welcome back, Arduino enthusiasts! Today, we're leveling up our serial communication skills by exploring different ways to format and send data from our Arduino board. This is essential for making our projects more organized, readable, and adaptable to various applications. In our previous exercise, we sent simple text and numbers to the serial monitor, but Arduino can handle much more than that. It can send data in various formats, including decimal, hexadecimal, binary, and even floating point numbers. Let's dive into how it works. Code breakdown. Number 1. Variables. We're using three variables to demonstrate different data types. First is value, a character variable holding a letter A or ASC11 value 65. 2. Int value, an integer variable with a value 65. Third, float value, a floating point variable with a value 65.0. Number 2, setup, open and close parentheses. Serial.begin, open parentheses, 9600 close parentheses, initializes serial communication at 9600 bits per second, just like before. Number 3, loop, open and close parentheses. Here's where the formatting magic happens. For the character, serial.println, open parentheses, quotation char value, colon, quotation, close parentheses prints a label for clarity. Serial.println, open parentheses, char value, close parentheses, prints the character itself, A. Serial.println, open parentheses, char value, comma, DAC, close parentheses, prints its decimal ASC11 value 65. And for the integer, serial.println, open parentheses, quotation, int value, colon, quotation, close parentheses, prints a label. Serial.println, open parentheses, int value, close parentheses, prints the integer in its default format 65. Serial.println, open parentheses, int value, comma, DEC, close parentheses, explicitly prints it in decimal 65. For serial.println, open parentheses, int value, comma, hex, close parentheses, prints it in hexadecimal 41. Serial.println, open parentheses, int value, comma, OCT, close parentheses, prints it in octal 101. Serial.println, open parentheses, int value, comma, BIN, close parentheses, prints it in binary 1000001. And for float, serial.println, open parentheses, quotation, float value, colon, quotation, close parentheses, prints a label. For serial.println, open parentheses, float value, close parentheses, prints the floating point value 65.0. Delay, open parentheses, 1000, close parentheses, pauses for 1 second. Char value plus plus and int value plus plus increments the value for the next loop. Experimenting with formats. Upload this code to your Arduino and open the serial monitor. Observe the different format options for each data type. Try changing the values and formats to see how the output changes. Consider scenarios where different formats might be useful, like sending sensor reading into decimal or hexadecimal, debugging code by printing values in different bases, communicating with other devices that require specific data formats. Remember, formatting data correctly is crucial for clear communication between your Arduino and other devices of programs. Keep practicing with different formats and explore their application in your projects. Stay tuned for more Arduino adventures. Problem 3. Receiving serial data in Arduino. Hey there, Arduino masterminds! Ready to take our serial communication skills to the next level? Today, we're flipping the script and teaching our Arduino boards to receive data from the outside world, like commands from our computer or input from other devices. Let's dive in. In previous episodes, we mastered sending data from Arduino. But what if we want to control our projects remotely or react to external information? That's where receiving data comes in. Receiving digits and blinking LEDs. The number 1, code breakdown. Variables. Char value, stores the received character digit from 0 to 9. Int value, stores the integer value of the received digit. Float value, you can ignore this for now as we're focusing on digits. Setup, open and close parentheses. Serial.begin, open parentheses, 9600, close parentheses, initializes serial communication. Loop, open and close parentheses. If open parentheses serial.available, open and close parentheses, checks if data is available in the serial buffer. Char value equals serial.read, open and close parentheses, reads the first available byte or character. Int value equals char value minus apostrophe 0 apostrophe colon converts the character to its integer value. Digital write, open parentheses 13, high, close parentheses, turns on the LED. Delay, open parentheses, int value times 100, close parentheses, blinks the LED for a duration proportional to the digit. Digital write, open parentheses, 13, low, close parentheses, turns off the LED. Testing it out. Number 1, upload the code to your Arduino. Number 2, open the serial monitor. Number 3, type a digit from 0 to 9 and press enter. The number 4, observe the LED blinking at a rate corresponding to the digit you entered. Applications. Remote control controls robots, lights, or other devices from your computer. For sensor readings, receive data from external sensors and react accordingly. And for interactive projects, create projects that respond to user input. Remember, receiving data is a powerful tool for making our Arduino projects more interactive and responsive. Stay tuned for more exciting serial communication adventures. Problem 4. Using a switch. Welcome back, Arduino enthusiasts! We're continuing our exploration of switches and interactive today, diving deeper into the code that makes it all happen. Grab your Arduino boards and let's light up some LEDs. Code breakdown. Number 1. Constants. LED pin equals 12 will assign pin 12 to control the LED. Input pin equals 2 assigns pin 2 to read the switch input. Number 2, setup, open and close parentheses. Pin mode, open parenthesis, lead pin, comma, output, close parenthesis, configures pin 12 as an output to send signals to the LED. Pin mode, open parenthesis, input pin, comma, input, close parenthesis, configures pin 2 as an input to read signals from the switch. Number 3. Loop, open and close parenthesis. Val equals digital read, open parenthesis, input pin, close parenthesis, reads the current state of the switch, which is high or low. If open parenthesis val equals high, close parenthesis, check if the switch is pressed. Digital write, open parenthesis, lead pin, comma, high, close parenthesis, turns the LED on. Else, if the switch is not pressed. Digital write, open parenthesis, lead pin, comma, low, close parenthesis, turns the LED off. Key points. Digital read, open and close parenthesis. This function reads the digital value for high or low from a specified pin. Digital write, open and close parenthesis. This function writes a digital value for high or low to a specified pin controlling outputs like LEDs. Pin mode, open and close parenthesis. This function sets the mode of a pin as either an input or an output. If statement. This conditional statement allows for decision making based on a condition, enabling different actions based on switch states. Testing and troubleshooting. 1. Upload the code to your Arduino. 2. Observe the LED's behavior when you press and release the button. 3. If the LED doesn't respond, check the wiring connection and ensure that resistor is in place. Number 4. Verify that correct pin numbers are used in the code. Keep exploring with switches and code, and you'll be creating incredible interactive projects in no time. Stay tuned for more Arduino adventures. Problem 5. LED react to switch. Hey, Arduino aficionados! Ready to dive deeper into the realm of sensors and feedback? Today, we're exploring how to create interactive projects that respond to the world around them, using a humble push button as our sensor and an LED as our visual indicator. Let's get started! Sensors and feedback, the heart of interaction. Sensors are like our Arduino's eyes and ears, gathering information from the environment. Feedback is how our projects communicate with us, letting us know what's happening. Together, they inform the foundation of creating interactive experiences. Code breakdown. 1. Assigning roles. Button pin equals to the pin listening for button presses. LED pin equals 12, the pin controlling the LED's light. Button states equals 0, a variable to store the button's current states. Number 2. Setting the stage. Setup, open and close parentheses. For pin mode, open parentheses, lead pin, comma, output, close parentheses, declares the LED pin as an output, ready to shine. Pin mode, open parentheses, button pin, comma, input, close parentheses, declares the button pin as an input, eager to hear button clicks. Number 3. The loop of interaction. Loop, open and close parentheses. This is where the magic happens continuously. Button states equals Digital read, open parenthesis, button pin, close parenthesis, asks the button, "Are you pressed?" and stores the answer, high or low, in button state. If open parenthesis button state equals high, close parenthesis, if the button is indeed pressed. Digital write, open parenthesis, lead pin, comma, high, close parenthesis, tells the LED to light up, signaling the interaction. Else, if the button is not pressed. Digital write, open parenthesis, a lead pin, comma, low, close parenthesis, instruct the lead to take a break, conserving energy. Testing and observing. 1. Upload the code to your Arduino. 2. Press the button and watch the LED come to life. Release the button and it gracefully fades. 3. You've just witnessed the fundamental concept of sensing and feedback in action. Congratulations, Arduino explorers! You've now harnessed the power of sensors and feedback to create simple interactions. Imagine the possibilities when you combine more sensors, outputs, and creative code. Stay tuned for more adventures and as we delve deeper into the world of Arduino. Problem 6. Reading analog values. Welcome back, Arduino adventures! Ready to unlock the secrets of the analog world? Today, we're diving into the realm of analog sensors, where voltage levels whisper fascinating stories. Grab your potentiometers and let's illuminate some LEDs. Analog values, a world of infinite possibilities. Our world isn't just black and white, on or off. It's filled with subtle shades and nuisance. It's filled with subtle shades and nuances. Analog sensors capture these variations in voltage, like a dimmer switch or a volume knob. Arduino can read these values, opening a whole universe of analog input possibilities. Code breakdown. Number 1. Pin assignments. Pot pin equals 0. This pin listens to the potentiometer's voltage whispers. LED pin equals 13. This pin controls the LED's bright beacon. Val equals 0. This variable stores the captured analog values. 2. Setup for storytelling. Setup, open and close parentheses. Pin mode, open parentheses, LED pin, comma, output, close parentheses, prepares the LED to shine with analog intensity. 3. The loop of analog magic. Loop, open and close parentheses. This is where the analog story unfolds over and over. Val equals analog read, open parentheses, pot pin, close parentheses, listen to the potentiometer's voltage tail and stores it in val. Digital write, open parentheses, lead pin, comma, high, open parentheses, turns the LED on, ready to reveal the analog secrets. Delay, open parentheses, val, close parentheses, pauses for a moment, letting the LED's brightness reflects the captured voltage. Digital write, open parentheses, lead pin, comma, low, close parentheses, turns the LED off, creating a pulsating rhythm that mirrors the analog changes. Delay, open parentheses, val, close parentheses, pauses again, ensuring a dynamic visual representation of the analog world. Testing and witnessing the analog symphony. 1. Upload the code to your Arduino. 2. Turn the potentiometer knob and observe the LEDs dance. It brightens and dims, echoing the analog variations. 3. You've just harnessed the power of analog input to create a symphony of light. Congratulations, Arduino explorers! You're now fluent in the language of analog sensors. Imagine the possibilities when you become these readings with other components and creative code. Stay tuned for more adventures as we explore even more fascinating ways to interact with the world around us. Problem 6. Displaying voltages up to 5 volts. Welcome back, Arduino Voltage Virtuos. Today, we're turning our Arduinos into digital full meters, capable of measuring and displaying voltage with precision. So grab your sensors and let's get ready to read those voltages like pros. Unveiling the voltage mystery. Arduino's analog pins can sense voltage between 0 and 5 volts, but they speak in a language of numbers, not volts. To translate these readings into meaningful voltage values, we need a bit of mathematical magic. Code breakdown. 1. Assigning the pin. Battery pin equals 0. This pin listens to the voltage we want to measure. 2. Opening communication. Setup open and close parentheses. Serial.begin open parentheses 9600 close parentheses starts a conversation with the serial monitor, our trusty voltage display. 3. The loop of voltage translation. Loop open and close parentheses. This is where the voltage reading come to life. Val equals analog read open parentheses battery pin close parentheses listens to the voltage on the pin and store it as a number open parentheses 0-1023 close parentheses. Serial.println open parentheses val slash open parentheses 1023 slash 5 close parentheses divides the reading by 1023, which is the maximum value, and then multiple by 5 volts, converting it to volts and printing it to the serial monitor. Serial.print open parentheses apostrophe dot apostrophe close parentheses add a decimal point for precision. Serial.println open parentheses val percent open parentheses 1023 slash 5 close parentheses prints the digital part of the voltage for even more detail. Delay open parentheses 500 close parentheses pauses for 500 milliseconds before the next reading, giving us time to absorb the voltage information. Testing and witnessing the voltage revelation. 1. Upload the code to your Arduino. 2. Open the serial monitor. 3. Observe the voltage readings displayed in real time. Twist a potentiometer, connect a battery, or measure a sensor's output and witness the voltage changes reflected on the screen. Congratulations, voltage whisperers! You've unlocked the power to measure and display voltages, opening up a world of possibilities for monitoring and controlling electronic devices. Stay tuned for more adventures as we explore even more ways to interact with the electrical realm. Problem 8. Responding to changes in voltage. Hey voltage vigilantes! Welcome back to another electrifying episode of Arduino Adventures. Today, We're empowering our Arduinos to become voltage watchdogs, constantly monitoring for changes and taking action when thresholds are crossed. Let's dive into the code and see how we can create a proactive alert system. Voltage watchdogs, keeping a close eye on the volts. Imagine your Arduino as a tireless sentinel, always watching over the voltage levels in your project. It's like having a built-in alarm system that can trigger events or alerts when things go wrong. This is crucial for projects that rely on stable power sources like battery-powered devices or those connected to external sensors. Code breakdown: Unleashing the watchdog's powers. 1. Setting the boundaries. We start by defining two crucial thresholds. Warning thresholds: the level where a friendly warning is needed. Critical threshold: the level where things get serious and immediate action is required. 2. Preparing the LED for signaling. In the setup, open and close parenthesis function, we configure the LED pin as an output, ready to communicate the voltage status. Number 3. The loop of vigilant monitoring. The loop, open and close parenthesis function tirelessly takes readings from the battery or sensor. It checks if the voltage has dipped below the critical thresholds. If so, the LED light up steadily, signaling a dire situation. If the voltage is between a warning and critical thresholds, the LED begins a flash with increasing urgency. The lower the voltage, the longer the flashes, creating a visual representation of the voltage decline. If the voltage is above both thresholds, the LED rests, indicating that everything is running smoothly. The flashing function, a visual Morse code. The flash, open and close parenthesis function, is responsible for creating an attention-grabbing flashes. It turns the LED on, pauses for duration based on the voltage level. Lower voltage means longer flashes. Turns the LED off and then pauses again to create a rhythmic pattern. Testing and witnessing the voltage watchdog in action. 1. Upload the code to your Arduino. 2. Connect your battery or sensor. 3. Observe the LED's behavior as the voltage changes. Steady light for critical levels, urgent flashing for warning levels, peaceful darkness for normal levels. Congratulations, Voltage Guardians! You're now equipped your Arduino with the ability to monitor voltages and respond proactively to changes, ensuring the safety and reliability of your project. Stay tuned for more voltage taming adventures as we explore even more ways to harness the power of electricity.